In this class, we're going to consider the trigonometric functions. So the trigonometric functions are the sine function, the cosine function, and the tangent function. So when you first learn about these guys, it's usually in the context of SOHCAHTOA, which is the trigonometric ratios. So that's when you've got sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and that's a reference to a right angle triangle where we label one of the angles as our sort of reference angle. So let's say that this angle down here, x, is going to be our reference angle, and then we say that that side there is opposite, this guy is adjacent, the one that's like touching that angle, and then the long side is the hypotenuse. And that's where we get our definitions from. So we say that, for example, sine, so we would say that sine, the sine function of the angle x, so sine x, equals opposite over hypotenuse, so that would be O over h. And then we do the similar thing for cosine and the similar thing for the tan function. But what we don't do at that point is really think about what are these functions? Like, what is sine, cos, and tan? Well, we're familiar with them from here and probably from seeing them on the calculator, and maybe thinking about what they do on the calculator is not a bad example because they're functions, they're performing a function, and the function that they're performing is to turn an angle. So remember that x is an angle here, is to turn an angle into some numerical value. So the input of a trig function, so sine, cos, or tan, is to take some angle and turn it into a number value. And that's kind of what we're exploring here with SOHCAHTOA. Where you eventually want to go though is to study the functions sine, cos, and tan, and there's other trig functions as well. There's inverse sine, which is called arc sine, arc cos, arc tan. There's hyperbolic sine. There's reciprocal sine. They go on for quite, well, not quite forever, but there's quite a few of them. So trig's a very big topic. But what we want to do is eventually start looking at these functions themselves and think, well, I know it does something. It performs this, operation of turning the angle into a number. Can I get a bit more about that? Like what else can I figure out about that process? So in this class, we're just going to kind of explore that and take that to a certain point. And then in other classes, I explain a bit further about how that works. But taking SOHCAHTOA as our starting point, let's say that we were to take an actual example. So let's take a right angle triangle. And we're going to put some measurements on this one. So let's say that this guy down here is 30 degrees. Just going to straighten up my triangle. It's got a bit of an angle there. Let me try that again. So I think that looks a bit better. So we've got a triangle and this is 30 degrees, a right angle triangle, so that would make that 60 degrees up in here. And we're going to put some measurements on this one. So this is 1, and this is root 3, and this is 2. So if you get further into trigonometry, you'll get quite familiar with this triangle, but by Pythagoras you could check that these numbers are correct, and that is the setup with the angles. So if we wanted to use sine, for example, with 30 degrees as a reference angle, so remember that if you're switching reference angle, you need to switch your labels. If that's our reference angle, then this here is opposite. This is always hypotenuse, the long side of the triangle, and that would be our adjacent. So if we're doing the sine function, so the sine of 30 degrees, so we're putting 30 degrees into our calculator, if you like. It's just that we're doing it manually. We're doing it in our brain calculator, not in the actual calculator. Although you could, if you put it in the calculator, you would get the same answer. So we're doing opposite over hypotenuse because that's what sine is. So opposite is 1, hypotenuse is 2, so it's 1 over 2, in other words, 0.5. If you push sine 30 on your calculator, you will get 0.5 or 1/2. So that's basically what has happened there. This number, 30, we've put that into the sine function. The sine function has turned that into the number 1/2. Similarly, if we were to take the cosine, let's take the cosine of, let's make it 60 degrees. So for the 60 degrees, we'll need to switch those around. If that's now our reference angle, then that's now opposite over here. This is adjacent, and the hypotenuse stays the same. So the cosine of 60 degrees, cosine from SOHCAHTOA is adjacent over hypotenuse. adjacent this time is over here, which is 1. Hypotenuse is still 2, so that also gives you 1 over 2. So the input there was 60 degrees, the output is 1 over 2. So notice that that's kind of weird, right? They've both come out to be 1 over 2. That's because actually these functions are closely related. They're the same function, just kind of shifted over a little in some sense. So that's just starting to feel our way into what these functions do. If we start looking at the graphs of these functions, and you might not know what I'm talking about by the graph of the function, or maybe you've seen these before, but when we plot all of these points, so for example, if we plot along the way the angles that we're putting into the function, so let's say that, we're going to capture like 30 degrees and 90 degrees and all of those, then that is the measurement that's going to go along this way, along the x-axis. Those are going to be the angles, and then up and down the way are going to be these numbers, the numbers we're getting out from the calculator. If you plot all of those points, and it turned out that a sine graph looks like this. Okay, it's got this kind of wave shape, and we call that one cycle of the sine graph. This point here in the middle is at 180 degrees. This point at the end is at 360. This guy here is at 90. This is at 270. This highest value going up and down the way here is at 1, and the lowest value, the minimum value, is at -1. So to take the example that we had, the sine of 30 equals 1/2. So 30 is about here, so 30 degrees. If you draw a line up till it hits the curve and then over to the y-axis, that value there is 1/2. So that's what it means for the sine of 30 to give you 1/2. If you look at its graph, if you go along 30 and you go up, you would correspond to 1/2. That's basically how they work. Similarly, this point here, which has got an up and down value of 0, that's at 180. So that would tell us, just looking at the graph, that the sine of 180 degrees equals 0. Similarly, this point here, which is at, now in fact, let's do this one here, the one which is at 270 degrees, just by looking at the graph, that 270 degrees, so this one here, corresponds to that lowest point on the graph, which is -1. So that's what it means to be gaining values from a trig function. We can do the same for the cosine graph. I'm not going to show that one in as much detail, but the cosine graph just looks like the sine graph, just shifted over a little, like I said earlier. So it comes out to look, well, that was a very rough sketch, but it looks something like that. And again, this is the maximum value 1, minimum is at -1, and then all these key points occur every 90 degrees. So 90, 180, 270, and then the end point is at 360, and that's the cosine function. So that was a very quick introduction to the sine function, but even just by doing that, we're already starting to get more information about how to work with trig values for sine. It would be the same for cosine. It would be the same for the tan function as well. The tan function is more complicated. It makes a more demanding graph to draw. But as soon as we start to move away from just thinking of these guys in terms of triangles and start to study them as functions in their own right, then it opens up a whole new world of thinking about trigonometry. And really, this is where you want to go. This is your starting point. This is fine. If this is where you are, it's perfect. That's where everyone starts. And you kind of develop through these kind of exact values, they're called. And then we move over to start to study the functions themselves and then variations on the functions. We think about, for example, starting to stretch these graphs like left and right and up and down, and we flip them around. And that opens up a whole new world of trigonometry. And if you're going to go through pre-calculus and calculus in the future, you're going to see all of that. So it's really good to get an early grasp on these trig concepts, to start to study the functions as early as you can, because they're one of those things that never go away, I'm afraid, much to a lot of students' dislike. Trigonometry stays with you throughout your whole math career, so the sooner you can get down with it, the better. So that's just an overview of the trigonometric functions, not really looking at tan. It's got a whole other world of complexity, but looking a little there at sine and cosine.